So our goal, which would be highly disruptive in a positive way were it to succeed, is to create self-contained greenhouses which provide their own water, their own light, and their own CO2 anywhere in the world by taking advantage of advanced porous materials that have been developed partly through the Molecule Water or Aquasorb project, and also partly through more basic research that was funded by the SFI. The Future Innovator Prize is aimed at grand challenges, one of which, the program that we're involved in, is called the Zero Emissions Challenge. So essentially it's a call for proposals from groups in Ireland, teams in Ireland, that will come up with innovative approaches to grand challenges. In our case, we took the zero emissions one step further to negative emissions, hence the term C-, which in the context of carbon is where you want to be.
We're very keen to work with other partners on developing multidisciplinary sustainability solutions for horticultural systems, particularly for deployment in semi-arid regions of the world and that are suffering from water stress, particularly in peri-urban areas of cities. We see a major need and a major opportunity to combine our knowledge and our expertise with that of our colleagues in C- to be able to deliver solutions into that space.
In the C- project, we'll be looking specifically at the economic and the greenhouse gas emission benefits of deploying the new sorbent technology in different formats. So we'll be trying to calculate the carbon footprint of manufacturing the sorbent and using the sorbent to extract CO2 and concentrate it, compared with other technologies that might be available at the moment to do that. Then we'll be looking at other ways that this CO2 concentration process might enable new technologies, disruptive technologies, such as the advanced horticultural systems where we can provide water and CO2 into systems in places which they wouldn't otherwise have been able to be implemented, such as arid zones or on rooftops of buildings, for example. We really want to understand the integration, especially of potentially building management systems and food production, and the efficiencies that we can achieve in terms of energy, in terms of greenhouse gas savings, land savings, etc. So it's really bringing that systems thinking to evaluate these systems and the net environmental benefits.
Molecule was selected to be part of the C- project, largely based on our existing relationship with the University of Limerick. We've been taking early stage water sorption materials and bringing them to the marketplace in the form of an atmospheric water generator. Along this path, we've had to define a complete supply chain in order to put these sorbents into an acceptable form for commercialization. One of our key partners along this path has been Thermistor. Thermistor is a natural fit for us because, one, they're open to new ideas and new technology, and the other is they are experts at environmentally controlling large spaces, especially greenhouses.
In a more general way, we bring the manufacturing and engineering know-how on how to make products and how to make products in on assembly line in a reproducible manner at a high quality with a reasonable cost. We can bring concept to market within 9 months. So we bring essentially not only our refrigeration expertise, but we bring the manufacturing and engineering know-how.
I think we should see carbon negative as a horizon point, and if we can get to carbon neutral on that journey, then we're already succeeding. But it is a destination point that we should be trying to push horticultural covered, protected or greenhouse-based horticultural systems towards. If we can achieve that flipping point from carbon neutral to carbon negative, then we'll have done humanity a great service.
Our goal is to grow food anywhere on the earth at any time, regardless of the environmental conditions, in a self-contained greenhouse, where there's no need for electricity, water, or sunlight.